Hi, so this is the third part of our lesson on 1.2, and this time we will be focusing on estimation using mathematical models. Now, before I continue with the third example, I would just like to give a quick correction about the discussion that I had with the line graph from the previous example. So, like I said, I would like to make a correction about this particular example here because I realized the mistake that I made after I already completed the video, and so I would just like to correct that we got the 50% of seniors that used alcohol. It is not 1995. If you observe, the dot is a little bit above the 50%. The exact the dot, the point that is exactly on the 50% mark is this one. So I would like to make that correction that instead of the year 1995, it was the year 2000 when 50% of the seniors use alcohol. Okay, so please, I apologize for that correction if I caught it a little bit late from the previously recorded video. Anyway, moving forward, so we're looking at mathematical models. So when we talk about using mathematical models, just think of it like you are trying to find a formula to describe a situation, to describe a real phenomena, a real world phenomena, okay? So let's have this example, okay? So I will walk you through how we can create the mathematical model for this. So you can see here on our bar graph, okay, that this is a representation of the average cost of tuition fees at a public four-year U.S. college, okay? So in the year 2000, around $3,362 is the average tuition fee. Now you can see that every year, that tuition fee gets to increase, right? So by the year 2010, it almost is pretty much double the original tuition fee from the year 2000, all right? So first question is estimate the yearly increase in tuition fees. Now this question, this is similar to what we did on the bar graph example from the previous video lesson. So when we are looking at the yearly increase, so it means that we need to find the difference, difference of the costs, okay? So it means highest cost minus the lowest cost, and then divide it by the total number of years, okay? How long did the change happen? So in this case, our highest cost of the tuition fee and the latest happened in 2010, and the highest cost was 720. The initial value for this data was in the year 2000, and we began with a 3,362. So if we are going to put those numbers into this setup, the difference of the cost would be written as 7,020 minus the original value, which is 3,362. And then whatever that difference, we need to divide it by the number of years. Now, as you can see, we started from 2000 and it ended at 2010. So even without doing your subtraction, we know that that is going to be over a 10-year span. So if you subtract 7020 by 3362, that is going to be 3,658, and if you divide it by 10, that's going to be 365.8. Now, it's going to be a little bit different. You know that when we are talking about estimation, we prefer nicer numbers, right? So we can remove the decimal area here and round it off to the nearest whole number. So our estimate is that every year there is an increase of $366. Okay? So that is our estimate yearly increase. Now, when we have that estimate yearly increase, then we can make a prediction for future years if we're going to look at the data. So how will our mathematical model, how will our formula look like if we want to predict the value of the tuition fee anytime, any year? Okay, so this one also looks a little bit familiar because it will follow the same scenario when we had the bar graph. Wherein when we are predicting future values, we always start with the initial, oops, sorry, I don't know why that happened. Forgive me for that. So let me erase that. Okay, so we are going to start with the initial value. Okay, we start with the 362, and then we add, how much does it increase every year? According to our computation from the previous slide, it's always $366 every year. Forgive me for the bell on the background. Okay, so there is an increase of 366 every year. How many years are we talking about? Well, we don't know. So that is why we will use the variable x to represent the number of years. Okay, so that is always the setup that we will be using. So if we replace the initial value, that is actually 3,362 plus our yearly increase multiplied by the number of years that we are talking about. All right? So please make sure you remember this because we will be using this on the next question. So here, let's use the mathematical model so that we can project, we can predict how much will be the tuition fee in the year 2016. So going back, our mathematical model is 3,362 plus the yearly increase of 366 multiplied by the number of years. Okay? So as you can see, we are going to predict the value of the tuition fee by the year 2016. If you would remember, our initial year was the year 2000. So I think that is pretty obvious that the number of years, so that would be, 2016 minus the year 2000, so that's 16 years all in all, okay? So that is the value of x that we will place in here. So rewriting the expression, this is 3,362 plus the increase yearly of 366 for over 16 years. So you can use your calculator to work on this. We will get 3,362 plus multiplying 366 and 16. That is a total of 5,856. And if you add this two, you will end up getting around 9,218. So that is our predicted tuition fee when 2016. Looking at the pattern that we had from the previous graph, this is our predicted value. So using our mathematical model, the average cost by the year 2016 is going to be, as we have said, 9,200. Okay, 9,218. And so that's that. So remember, when we are estimating values, we are not getting an exact value. We're giving an approximation, a near value that could be representative of our exact value. We can do it by using rounding numbers. We can use graphs on it, and also we can use mathematical models to predict some future values. Thank you.